Welcome to Conversion Factor Basics. When we need to change from one unit to another, we use what's called a conversion factor. A conversion factor is a ratio, which means a fraction, that's made from two quantities that are equal to each other. That is, a conversion factor must equal 1. And if the numerator and denominator of a fraction are equal, then the fraction is equal to 1. For example, 7 divided by 7, or 7 over 7, is equal to 1, because anything divided by itself is 1. And because we know that 1 milliliter is equal to 10 to the minus 3 liters, we can then say 10 to the minus 3 liters over 1 milliliter is equal to 1 milliliter over 1 milliliter, and that's equal to 1. Alternately, we can say 1 milliliter divided by 10 to the minus 3 liters is equal to 1 milliliter over 1 milliliter, and that's equal to 1. But we also know that 1 liter is equal to 1,000 milliliters. So we can say 1,000 milliliters divided by 1 liter equals 1 liter over 1 liter, and that's equal to 1. And 1 liter divided by 1,000 milliliters is equal to 1 liter over 1 liter, which is equal to 1. And note here that any fraction that equals 1 can be flipped, and it will still equal 1. So we can have the 1,000 on the top and the 1 liter on the bottom, or we can have the 1 liter on top and the 1,000 milliliters on the bottom, and they both equal 1 because 1 divided by 1 is still itself. You can make a conversion factor or a fraction out of any quantities that you know to be equal. Because you know the prefix definitions, then you should be able to form some conversion factors for getting from a base unit to a prefixed unit and vice versa, from a prefixed unit back to the base unit. And this means that we can then use one conversion factor to get from a prefixed unit to our base unit, and then another conversion factor to get from our base unit to a different prefixed unit. For example, 1 meter is equal to 10 decimeters, which is 100 centimeters, or 1,000 millimeters. And that means that we can write 1 meter over 1 meter is equal to 10 decimeters over 1 meter, which is equal to 100 centimeters over 1 meter, which is equal to 1,000 millimeters over 1 meter, and all of these are equal to 1. Note here that the textbook authors prefer to use the 1 prefix ratios, so they're writing it as 1 meter over 1 meter, or 1 decimeter over 10 to the minus 1 meter, or 1 centimeter over 10 to the minus 2 meters, or 1 millimeter over 10 to the minus 3 meters, and all of these are still equal to 1. And note here that the textbook presents two different systems, the 1 prefix and 1 unit definitions. And you can use whichever you prefer, but I highly suggest not switching between them. So pick either the 1 unit system or the 1 prefix system and stick to that. Personally, I actually use both systems. For the small prefixes, I use the 1 unit system. So I say something like 1 meter is equal to 10 to the 9 nanometers. So I say 1 meter over 10 to the 9 nanometers is equal to 10 to the 9 nanometers divided by 1 meter, and each of those are equal to 1. And then for large prefixes, I use the 1 prefix system. So I say something like 1 kilometer is equal to 10 to the 3 meters. So 1 kilometer over 10 to the 3 meters equals 10 to the 3 meters over 1 kilometer, and this equals 1. And this allows me to use 1 of whichever is the larger unit, either the base or the prefixed unit, and 10 to the n of the smaller units, where n is some positive integer. And this allows me to avoid using any negative integers in my exponential term. And yes, I know that this goes against my advice to stick with 1 system, but this is the way that I learned it, and so this is the way that makes the most sense to me. So you should find the way that makes the most sense to you, and you should stick with that method always. If this is my hybrid method, or if it's the 1 prefix method, or it's the 1 unit method, whichever method works for you, use that method, but just bear in mind that switching back and forth between the 2 methods is a little bit more complex. Although there are some advantages to it, as I outlined here. So, how do we actually use our conversion factors? So let's look at an example. Let's convert 7.5 kilometers to meters. We know that 1 kilometer is equal to 10 to the 3 meters, 1,000 meters. So we can say that 7.5 kilometers times 10 to the 3 meters divided by 1 kilometer. And now we can do a little bit of rearranging. We can then rearrange our numbers, and we can say 7.5 times 10 to the 3 divided by 1, so we're going to ignore that, divided by 1, times now our units. And now we have kilometers times meters divided by kilometers. So we have kilometers times meters divided by kilometers. Well, our kilometers there cancel, leaving us just with meters. Remember here that we're doing our number, exponential, and unit math separately. So multiplying a quantity by a conversion factor does not change the quantity. It only changes the units. It only changes the way that that quantity looks to us. So why? When we know that multiplying anything by 1 or dividing by 1 doesn't change that quantity. That quantity is still exactly the same. And a conversion factor must be equal to 1. So all we're doing here is multiplying by 1. We're not changing that quantity at all. We're just changing the way it looks. We're just changing the units on it. So this means that multiplying by a conversion factor doesn't change our quantity. It just changes the way that our number looks. So 7.5 kilometers is exactly the same distance as 7,500 meters. Same number of sig figs in each case. When you need to change from one unit to another, you can then multiply by a conversion factor to cancel one unit and substitute it with another. And you can do this with any two units, so long as you know a ratio between the two units that equals 1. It doesn't have to be units of the same type, so you don't have to be converting from a length unit to another length unit. You could convert from a length unit to a mass unit or a volume unit, as long as you have a ratio that you know is equal to 1 between those two units. And that was conversion factor basics.